For this example, we are given a point that lies on the terminal side of an angle theta that's drawn in standard position. And we're asked to find the exact value of each of the 6 trig functions. So that's the sine, cosine, tangent, cosecant, secant, and cotangent of theta. So first, let's draw our angle in standard position. So we have the vertex at the origin. The initial side lies along the positive x-axis. And then with the point being at negative 3, 4, so it's going to be somewhere here, negative 3, 4. That tells us that our terminal side is going to lie in quadrant 4. Maybe it's going to be somewhere like here, like I said. And so let's construct this angle here. So this is our angle in standard position. Now, in order to find the trig functions of theta, right, of this angle, we need to construct a right triangle. So we're going to construct a right triangle. Construct our right triangle here. So we have a right triangle. And let's use this right triangle to help us find our trig values, the values of the sine, cosine, tangent, secant, cosecant, and cotangent. So first we have to ask ourselves, what is the distance, this distance here, along the x-axis? Since we know that this ordered pair here is negative 3, 4, that means that the distance from the origin to this point in the x direction is 3. It's 3 units, and it's 3 units in a negative direction. And then this leg here of our right triangle, well, that's the change in our y coordinate, and we know that that value is 4. So this is 4, and it's in the positive direction. So we need to figure out the value of the hypotenuse, and you might recognize this as a Pythagorean triple. So it's a 3, 4, 5 right triangle. If you didn't recognize that, you could have used Pythagorean theorem. So we'd say c squared equals 3 squared plus 4 squared, which gives us c squared equals 9 plus 16, which tells us that c squared is 25, and so the value of c then is 5, which we saw is our Pythagorean triple. So let's find now all of the trig functions for theta. So let's find first the sine. So the sine of theta. So we're talking about the sine of this angle here. So the sine of theta is opposite over the hypotenuse. So it's 4 over 5. Let's take a look at the cosine. The cosine of theta is the adjacent side over the hypotenuse. So the measure of the adjacent side is 3, but it's in the negative direction, so it's going to be a negative 3 over 5. Now we also know that it should be negative because in the second quadrant, the cosine is negative. Remember, the cosine represents the x-coordinate, so in the x direction, it's negative in the second quadrant. The tangent of theta is our y divided by the x. So it's the opposite over the adjacent. So it's 4 divided by negative 3, which gives us negative 4/3. And then we can use our sine, cosine, and tangent to find the reciprocal functions. So we have the cosecant of theta, which is the reciprocal of our sine. So just take the reciprocal there. So it's going to be 5/4. We will have the secant of theta, which is going to be the reciprocal of our cosine. So it's going to be negative 5/3. And then we have the cotangent of theta, which is the reciprocal of our tangent. So that's going to be negative 3/4. And those would be our exact values of our 6 trig functions when we have a point negative 3, 4 that lies on the terminal side of our angle in standard position.